Hi everyone and welcome to today's Saturday session with ExamRevision. Today we're going to look at length, area and volume exam questions from the 2023 paper, 2022 paper and the SEC sample paper. So let's get started. So before we start looking at some exam questions, let's just look at some important formulas you have in your formula booklet. So starting on page 8, you have your first length and area formulas. So right down at the bottom, we have formulas for a circle. These formulas that are given to us are the length and the area of a circle. Just to keep in mind, they use L here for length, which is another way of writing the circumference of a circle. It's more than likely that the question is going to ask you for the circumference of a circle and not the length of a circle. Moving on to page 9, we have the formula to find the area of a triangle. Again, you might be used to seeing a half times the base times the height. Here they use a half times A times H. This is coming from this diagram over here, where we can see that the base of the triangle is labelled A. So it's the exact same formula. Instead of saying the base, they have A as the base. Page 10 of our formula booklets gives us some important formulas for surface area and volume. So we have the surface area for cylinder, cone and sphere here, while also having the volume formulas for each 3 of these shapes. Also important to point out here that A in all of these formulas represents the curved surface area. In some exam questions, you might be asked for the total surface area or the curved surface area. These formulas only represent the curved surface area. So make sure not to get these mixed up with total surface area in your exam questions. Okay, so let's start looking at some exam paper questions. This question comes from the 2023 paper and it asks, the students in a transition year mini company make and sell candles. They buy a solid rectangular block of wax measuring 35 centimetres by 45 centimetres by 16 centimetres. Part A of the question asks us to work out the volume of the block of wax. So the key points of this question, they want us to find the volume. And the shape that we're looking to find the volume of is a rectangular block. Another word for a rectangular block will be a cuboid. So the first formula I'm going to put down here is what is the volume of a cuboid formula. This formula is not in our formula booklet, so it's something you need to learn off by heart. And to get my marks straight away, I'm going to write down that that formula is the length times the width times the height. So they have given us these dimensions in our question. They have told us that the block measures 35 by 45 by 16 centimetres. So I will just write down what each one of those represents. So I'll say the length is equals to 35, the width is equals to 45, and the height is equals to 16. I can now input those directly into my formula. So my formula was length, which is 35, multiplied by my width, which is 45, multiplied by my height, which is 16. And inputting that into my calculator, I should get out 25,200. That represents the volume of this rectangular block of wax. Now, before we finish off this question, just make sure to look at your units. So what measurements were we talking about? We were talking about in centimetres. So add that in, and we're also talking about volume, so we raise that unit to the power of 3. So my final answer for this question is the volume of the block of wax is 25,200 centimetres cubed. Okay, part B of this question says the students are going to use this wax to make candles in the shape of cylinders. Each candle will have a radius of R centimetres and a height of 9 centimetres. Work out the volume of each candle in terms of R and pi. So again, this question is asking us to find the volume, and the shape they're asking us to find the volume of is a cylinder. So again, I'm going to ask myself, do I have a formula for the volume of a cylinder? And yes, I do. This formula is in my formula booklet. So if I open up my formula booklet on the correct page, I can input that formula first, again, to get me these nice easy marks. And that formula for the volume of a cylinder is pi r squared h. So pi r squared h means that we're going to multiply pi by the radius to be squared times the height of the cylinder. So before I input those values into my formula, the question has told me that the radius is r centimetres, the height is 9 centimetres. So from that, I can say that pi, we will just use pi, r will be r, and h will be 9. Now you might be asking yourself, how can I input r or pi into my calculator? We don't need to do anything with those because the question said at the very end to give your answer in terms of r and pi. What this means is we don't have to input any values for these. They are just going to be part of our answer at the very end. We will have pi and r in our answer at the very end. So now inputting these values into my formula, pi, I'm just going to use pi again. R is just going to be r to be squared, and then multiplied by h, which is 9. So if I can tidy this up as best I can, pi multiplied by r squared would be pi r squared, and then pi r squared multiplied by 9, we can just put the 9 in front and write it as 9 pi r to be squared. Now once again, we're talking about volume, so we need to put in our units. So our units we were talking about again was centimetres, and volume again to the power of 3. So this now gives us the volume of one of these candles is 9 pi r squared centimetres cubed in terms of pi and r. So I've just left pi and r in my answer. I don't need to do anything with those because the question told me to give your answer in terms of pi and r. Moving on to part C of this question, the students make 100 candles from the block of wax. In making the candles, 10% of the wax in the block is wasted. Use this information to work out the value of r, the radius of each candle, and give your answer correct to 1 decimal place. So this question is asking us to find out the value of r, the radius of each one of the candles that they make. To do this, I'm going to use the information at the start of the question, and I'm going to do this in 2 separate parts. Firstly, I'm going to find out what is the volume of 100 of these candles of wax, and secondly, I'm going to find out what is the volume of wax that was used from the original block that we started off with. When I get both of these answers will represent the same value, and therefore I can put them equals to each other and hopefully go and solve for r then. So firstly, I'm going to use the information from the first line of the question that the students made 100 candles from this block of wax. From part B, I found out that one candle had a volume of 9 pi r squared centimetres cubed. So if I want to find out what the volume of 100 candles will be, I need to take my value for one candle and multiply that by 100 to give me the volume of 100 candles. And 9 pi r squared multiplied by 100 will give me 900 pi r squared centimetres cubed. That's my first value for the first part of this question. The second part of my question, I want to use the second line of information that they have, that when they were making the candles, 10% of the wax in the block was wasted. If 10% of the wax in the block was wasted, that means that 90% of the block was used to make the 100 candles. So in part A, we found that the volume of the block was equals to 25,200 centimetres cubed. I want to find out what is the volume of 90% of this block, as that's how much was used to make the candles. To find 90% of this, I need to change 90% into a fraction or a decimal, so 0.9, and multiply that by 25,200. And that gives me 22,680 centimetres cubed. And that is my second important value for this question. So both these answers that I've underlined in red are equals to each other because the first answer represents the volume of wax it takes to make 100 candles, and the second answer represents the volume of wax that was used from the original block. So I can now put both of these answers equals to each other and create an equation to solve for r. So 900 pi r squared is equals to 22,680. And looking at this equation, the only unknown value that I have is r. So I should be able to solve this equation by balancing both sides. So trying to get the r by itself there on the left hand side, I need to remove everything else until I can get r by itself. So I'm going to start off by removing the 900 pi. So 900 pi is attached on by multiplication. So to remove it, I will divide by 900 pi. And I must do that on both sides to balance my equation. Once I do that on the left hand side, 900 pi will cancel and I will be left with r squared. On the right hand side, I can just input 22,680 divided by 900 pi. You will find the pi button in your calculator. This gives me a value of 8.02141. Now I have r squared on the left hand side. I don't want r squared, I want r. So to remove my square, I'm going to do the square root on both sides. So I'm going to square root the left and square root the right. That will finally leave me with just r on the left. And once again, inputting into your calculator the square root of 8.02141, it gives me an answer of 2.83221. So before I can finish off this question, it told me at the very end to give my answer to 1 decimal place. So rounding my answer there, I can see that 8 is in the 1 decimal place position and its neighbour 3 will keep that as 8. So my radius for one of these candles is 2.8 and my unit is centimetres. And that's my final answer. Okay, so moving on to the next question from the exam paper in 2022. It says a balloon pump is made from a cylinder with an internal diameter of 6 centimetres and a height of 20 centimetres as shown. Each time the pump is pumped, it passes 1 full cylinder of air into a balloon. Part A asks us to show that the volume of 1 full cylinder of air is 180 pi centimetres cubed. So in this question, they've already given us the answer. They've told us that the volume is 180 pi centimetres cubed. And they want us to show that this is the answer. So some students get confused by this and start working with the 180 pi, but they don't want you to do that. They've given you the answer. They want you to get the answer by using your own method. So again, ask yourself, what are they asking me to do here? They want me to find the volume, and the shape they want me to find the volume of is a cylinder. So we're going to say, do we have a formula for the volume of a cylinder? And yes, we do in our formula booklets. So that formula is the volume of a cylinder is equals to pi r squared h, which again means pi multiplied by my radius to be squared multiplied by my height. So in the question, they have given us some dimensions as well. They've told us that the internal diameter is 6 centimetres, and we can see that in the diagram as well. And they've told us that the height of the cylinder is 20 centimetres. And once again, we can see that in the diagram. So to use my formula, I need to have a value for pi, I need to have a value for r, the radius, and I need to have a value for h, the height. So if we look at our answer again, our answer was given as 180 pi. They have given us the answer in terms of pi. So in our formula, we are not going to input any value for pi, or we're not going to use it in our calculator. We're simply going to just keep it as part of our answer. The radius next is not given to us in the question, but they've told us that the diameter is 6. We should know that the diameter is equal to 2 times the radius, or the radius is half the diameter. So if my diameter is 6, that tells me that my radius is 3 centimetres in length. And finally, my height was given to me in the question. They told me the height was 20 centimetres. So now I have all the values I need to input into my formula. So now inputting this into my formula, pi again, I'm not going to use any value for pi. Multiplied by r to be squared, r was 3 and we need to raise that to the power of 2. And then multiplied by my height, which is 20. Now, if you want, you can pop this into your calculator here, the second part of the formula, 3 squared multiplied by 20, or you can do it manually. So 3 squared we know is 9. And then 9 times 20 is 180, which gives me 180 pi. And again, put in my units, we're talking in centimetres, and it's raised to the power of 3. And we can see again, we get the exact same answer that they've given us in the question. So we have shown that the volume of this balloon pump is 180 pi centimetres cubed. So if we just take a look at the marking scheme for this question, we can see we have our answer here, 180 pi centimetres cubed. The centimetres cubed is probably in brackets there just to say that it's okay if you leave that out, but always really good to include that. So there was 5 marks going for this question. You can see partial credit is the 2 marks there. Okay, so you either got 0 or 5, and then you get partial credit for any little thing you do. So in putting the correct formula gave you marks if you found the radius, or if you just inputted into the formula and you forgot to finish off the question or put it into your calculator, that would have given you 2 out of 5 marks. So if you did any of those 3 things, you would have got nearly half the marks in that question. Part B of this question tells us that Dara is inflating a balloon in the shape of a sphere. When fully inflated, the balloon has a radius of 15 centimetres. Find the volume of Dara's balloon when it is fully inflated and give your answer in centimetres cubed in terms of pi. So again, in this question, it's asking us to find the volume of a shape, and that shape they're asking us to find is the balloon, which is in the shape of a sphere. So again, I'm going to write down, do I have a formula for the volume of a sphere? So to get my first set of marks, I'm writing down that the volume of a sphere is equals to 4 over 3 pi r cubed, which means 4 over 3 multiplied by pi multiplied by the radius of my sphere to the power of 3. So the values I need to input into my formula are pi and my radius. But the question has told me at the very end to give my answer in terms of pi. Therefore, I don't need to worry about pi. Pi will just remain as pi in my question. The question also told me that when the balloon is fully inflated, that it will have a radius of 15 centimetres. So the radius of my sphere is equals to 15 centimetres. Now I can input those values into my formula. So it's 4 over 3 multiplied by pi, which we're going to ignore because we want to give our answer in terms of pi, multiplied by 15 to the power of 3. So again, you can use your calculator there to work out what 15 to the power of 3 is. So 4 over 3 multiplied by pi multiplied by 15 to the power of 3, which is 3,375. To tie this up completely, I can multiply 4 over 3 by 3,375 in my calculator, which gives me 4,500. And don't forget your pi at the end. And we're also told to give our units. So we're talking in centimetres and we're talking about volume to the power of 3. And that gives us the volume of this inflated balloon in terms of pi. The second part of B tells us that Dara pumps the pump once every second. How many seconds will it take Dara to fully inflate his balloon? So from the previous part of the question, we know that Dara's balloon will get to a volume of 4,500 pi centimetres cubed. And we also know from part A that the cylindrical pump has a volume of air of 180 pi centimetres cubed. So the question is asking us that if Dara pumps his pump once every second, how long will it take him to reach the volume of this size for his balloon? So we need to figure out how many times the volume of the pump will go into the volume of the balloon. And that will tell us how many seconds it takes him to pump up this size of a balloon. So to do this, we're going to use the operation division, and we're going to see 4,500 pi, how many times we can divide into it 180 pi. And again, you can simply just use your calculator to do this. So inputting 4,500 pi divided by 180 pi, we get 25. So he needs to pump that cylindrical pump 25 times to reach the volume of the balloon, and that means that if he does one pump every second, it will take him 25 seconds to inflate the balloon. So just looking at the marking scheme again for this question, we can see that they treated part 1 and part 2 of B together. So that's why it's representing 10 marks, a bit more than part A. And there's a bit more detail in this marking scheme. So you have a low partial credit, which would give you 3 marks. You have a mid partial credit, which would give you 5. And then finally you have a high partial credit, which would give you 8. And then you have your 0 if you didn't attempt the question maybe, or you didn't get anything, to give you a low partial credit, and you have your 10 marks if you got everything correct. So again, we can see low partial credit there just by inputting in the formula. Maybe you made some attempts to add up 180 pi until you got to 4,500, but you didn't fully get there. The mid partial credit, then maybe you got part 1 or part 2 correct, or you did a really good job on working in both parts, but you didn't fully get to the correct answer. And then finally, your high partial credits, which have given you 8 marks, meant you had part 1 correct, and then you had good work of merit in the second part. And then maybe you may have put in the incorrect formula, but you still managed to finish the question correctly. So you made a mistake maybe at the start, but everything else was correct. They still would have given you 8 out of 10 marks there. So you can see just there from the right hand side, very easy to pick up over half the marks here if you're inputting in the correct formulas from your formula booklet, and then you work on your calculator correctly. And then really, if you make any good attempt at understanding the question or writing down maybe what you need to do, but you're not sure how to do it mathematically, really important to write down as much as you can in the boxes to pick up any marks, because you can see from the marking scheme there, they are giving marks for any little bit that you do. So the last part of this question says that Gustav is inflating a bigger balloon in the shape of a sphere. He also pumps the pump once every second. His balloon is fully inflated after 50 seconds. Find the radius of Gustav's balloon when it is fully inflated and give your answer correct to 1 decimal place. So again, I'm going to treat this question as 2 separate parts. Firstly, I'm going to find out what is the volume of Gustav's balloon. And I can find that out by multiplying how much volume of air is in one cylinder pump and multiplying that by 50, as he's doing 1 pump every second. That will give me the volume of his balloon, which I know is in the shape of a sphere, so therefore must be equals to the volume of a sphere formula. That will allow me to create an equation and hopefully allow me to solve for the radius. So firstly, I know that 1 pump of the cylinder will give you 180 pi centimeters cubed. He does 50 pumps. So to find out the volume of 50 pumps, I'm going to multiply this by 50. And that gives me 9,000 pi centimeters cubed. So that is the volume of this balloon that Gustav is inflating. Now I know that this balloon is in the shape of a sphere, so I can say that the volume of a sphere, which again is 4/3 pi r cubed, is equals to 9,000 pi, as they are both representing the same volume. So creating an equation, I can say 4/3 pi r cubed is equals to 9,000 pi. And I can solve for the radius here because r is the only unknown that I have in this equation. So balancing out my equation, I need to get r by itself on the left hand side. So firstly, I can remove 4/3 pi as they are attached to r by multiplication. So to remove them, I can divide by 4/3 pi. And I must do that on both sides. That will allow me to cancel out the 4/3 pi on the left hand side, leaving me with just r to the power of 3. And once I pop 9,000 pi divided by 4/3 pi into my calculator, I should get 6,750. Now to finally get the r by itself, I need to remove the power of 3. And to do that, I'm going to cube root the r to the power of 3, which I must also do to the right hand side. That will cancel out the power of 3 and finally just leave me with r. And the cubed root of 6,750 gives me 18.8988. So don't forget to look back up in the question, see what they ask you to round your answer to. They asked me to round it to 1 decimal place here. So that 8 here is in the 1 decimal place region. So I'm going to check its neighbour, which is 9, and see is it going to force the 8 to stay the same or move up. And it's going to make it move up. So my radius is equals to 18.9 and my unit again is centimetres. So that is the radius of Gustav's balloon. You can also see kind of, is my answer correct? They told me that the balloon was going to be a bigger balloon. The previous balloon had a radius of 15 centimetres. So this has a radius that's bigger. So that looks like I'm doing good there in that answer. Okay, the last part of this question, we can see this question was only worth 5 marks, even though it was probably the most difficult of all the parts. So it was worth just as much as part A, which would have been a relatively easy question. So again, they've broken it up to low, mid and high partial credit. So low partial credit would have given you 2. Mid partial credit would have given you 3 marks. And then finally, high partial credit would have given you 4 marks then. And you would have got 5 then if you got everything correctly. So just breaking it down, they kind of said how they would have expected you to solve it. So 4 steps: find the volume of the balloon, set up an equation, find r to the power of 3 is equals to 6,750, and then finally finds r. They're the kind of steps, and they're kind of marking you to see how far you get on those 4 steps. So you can see the low, mid and high is kind of worked out from that you get, if you get 2 steps correct, you get mid, 3 steps correct, you get high. Just important to point out the very end there, we can see that they're minusing 1 here if you don't round correctly, okay, or you don't attempt to round at all. So it's very important that you do round to what they ask. And then again, they're minusing 1 here if you don't include the units or you have the incorrect units there. So I've talked about that before. Really important, even if they don't tell you in the question to write the units, I would always write the units. So whether you're working in centimetres, metres, kilometres, whatever. And then if you're talking in terms of area, that you're putting it to the power of 2, or if you're using volume, that it's the power of 3. They might not necessarily say put your units in the question, but as we can see, they can just add that -1 credit, and it's kind of a silly marks to be losing there at the end if you've done the entire question correctly that you don't put in the units. So just always bear that in mind. Highlight in the question if they're asking you to round it, because it's very easy to forget once you're kind of finished the question, you're happy, you want to move on, that you forget to round to whatever place value that they asked you to round to. Our final question from the 2022 paper tells us that the diagram below shows the circle K. The points A, B and C lie on the circle, with AB being the diameter of the circle and AC equals to the length of 8 centimetres. It also tells that the area of the circle K is 25 pi centimetres squared. Work out the size of the smallest angle of the triangle ABC. So from our rules of geometry, if we have a triangle that's inside a circle and one of the side lengths is the diameter, that means that the opposite angle is a right angle. So in this case, A to B is our diameter. That means the opposite angle, which in this case is C, is equals to a right angle. That's one of your geometry proofs. Okay, so we now know that the triangle ABC is equals to a right angle triangle. Next thing that they tell us is they tell us that the area of the circle K is 25 pi centimetres squared. This is important to us because we know that the formula for the area of a circle is equals to pi r squared. And that can be found in our formula booklets. So if that's my formula for the area of a circle, and I know that the area of K is equals to 25 pi centimetres squared, I know that both of those are equal to each other. So pi r squared is equals to 25 pi. This will allow me to find out the radius of the circle. So using algebra, I can divide both sides by pi, which will give me r squared is equals to 25, and then square rooting both sides, will give me that the radius is equals to 5. That means that circle K has a radius of 5. We already said that AB was the diameter, and the diameter is twice the radius, so the length of AB must be 10. I've now found the side length of another side in my right angle triangle. I can now use my trig ratios from the trigonometry chapter to help me find the smallest angle. The smallest angle will be opposite the smallest side. We can see from the diagram that the smallest side is BC. So the smallest angle must be the angle at A. Now looking at my right angle triangle, I can decide which of my sides is my hypotenuse, my adjacent and my opposite side. Across from my right angle is my hypotenuse side. Across from the angle that I'm talking about is my opposite side. And then my third side is my adjacent side. So in this right angle, I know that my adjacent side is 8 and my hypotenuse side is 10. So I'll be working with those two. And my adjacent and hypotenuse give me the trig ratio cos. Now building my equation with my angle, I will call it angle A is equals to my adjacent 8 over my hypotenuse 10. My goal is to get A by itself on the left hand side of the equation, so I need to remove the cos. To do this, I will do cos inverse. And I must do that on the other side as well. That will cancel out my cos on the left hand side, leaving me with A is equals to cos inverse of 8 over 10. Inputting that into my calculator, that will give me 36.9 degrees. And that is my smallest angle in this triangle inscribed inside in the circle. Now it doesn't tell me in the question to round it to 1 or 2 or to the whole number, so you're kind of free to do whatever you want. Depending on what you get in your calculator, I would always round it up to 1 decimal place unless it's a whole number, or if the question asked you to round it up to a certain figure. Okay, so moving on to our next exam question comes from the SEC sample paper, and it tells us that a can in the shape of a cylinder has a radius of 3.6 centimetres and a height of 10 centimetres. Work out the volume of the can and give your answer in centimetres cubed, correct to 2 decimal places. So again here, we're working with the volume of a 3D shape, and that shape is a cylinder. So just like I've done previously, we're going to write down what our volume of a cylinder is. And that is pi r squared h, or pi multiplied by my radius to be squared multiplied by my height. Looking at my question, they have given me dimensions. They've told me that the radius is equals to 3.6 centimetres and that my height is equals to 10 centimetres. So I can say that these values, r is equals to 3.6, h is equals to 10, and pi, which I probably should have wrote first, as it comes first in my formula. They haven't told me to give my answer in terms of pi in this question, so I'm going to use pi in my calculator. So inputting those into my formula, pi will be used as the button in my calculator, multiplied by my radius to be squared, so 3.6 to be squared, multiplied by my height of the cylinder can, which is 10. And inputting that into my calculator gives me an answer of 407.1504. And the question told me to round this to the nearest 2 decimal places. So I would look at what number is in the place value that gives me 2 decimal places. That's 5, and its neighbour 0 will keep that as 5. So my final answer for the volume of this cylinder can is 407.15, and our units are centimetres, and we're talking about volume, which is cubed to the power of 3. Now, just the thing before I finish off this question, when you input that into your formula, pi times 3.6 to the power of 2 times 10, your calculator may give it to you in terms of pi. You can just simply press your S to D button and it will change it into a number that I got there, 407.1504. So just if that confused you, you have your S to D button in your calculator to help you get away from your answer being in terms of pi. Okay, so part B of this question then says that 24 of these cans are to be packed into a closed rectangular box. The cans will be arranged inside the box as follows. So we can see that we have 24 cans. We can see they're going up 2 cans, and then the length is 4 cans across and the width is 3 cans back. So it says write down the height, the length and the width of the smallest rectangular box that will be needed for these 24 cans. One is already done for you. So they've told us the length already. They've given us the length as 28.8. What they mean when they say the smallest rectangular box, they're basically just saying that you've no space left, that your box completely encapsulates all of those cylinders without having any gaps or anything. So if we firstly just talk, how did they get the length to be 28.8 centimeters? So we talked already that the length is 4 cylinders long. And we know from the previous question that the radius of one of these cylinders was 3.6 centimeters. So if we were to start here, the radius would go as the halfway point of the cylinder, and that would be 3.6 centimeters. So a full cylinder length would be the radius times 2, or the diameter, so it would be another 3.6. So one full cylinder length would be 7.2 centimeters. So our diameter length would be the length of one of these cylinders. We have 4 of these cylinders in the length, so we would have 4 times the diameter would give us the full length of this block. And 4 multiplied by 7.6 does indeed give me 28.8 centimeters. If we look at our width next, our width is 3 cylinders long. So again, we know that one cylinder would be 7.2. So our width would be 7.2 multiplied by 3. And 7.2 multiplied by 3 gives me a width of 21.6 centimeters. Finally, our height will have to be done a different method, because we're not using the diameter length here, we're using the height of the cylinder. The height of the cylinder from the previous question was 10 centimeters. So one cylinder goes up 10 centimeters. If there's 2 cylinders, it will go up another 10 centimeters, which will give us a height of 20 centimeters. So we now know that the height of our box that we will use to keep these 24 cans in is 20 centimeters. Our length, which was given, is 28.8, and our width is 21.6 centimeters. So really important to remember that when you're talking about your cylinder, when they're lined up, you see the full diameter of a cylinder if you were to look at it face on. And if we were to draw our box there, our box would be starting off here. It would trap the cylinders in there and trap them once again in here. And that would be one surface of our box. So the next part of this question carries on from that. It asks us to work out the volume of this box. So again, before I get started, I'm going to write down what is the formula for the volume of a rectangular cuboid, which is my length multiplied by my width multiplied by my height. Now, having that formula down, even if you got the previous part of the question incorrect, you would get your marks for knowing the formula for that volume of a box. So in the previous question, we said the height was equals to 20, my length was equals to 28.8, and finally my width was equals to 21.6. So inputting those into my formula, length 28.8 multiplied by my width 21.6 multiplied by my height 20, and popping that into my calculator gives me an answer of 12,441.6, and we were talking in centimeters and volume again to the power of 3. Now you notice in this question they didn't say rounded to the whole number or rounded to the nearest 1 decimal place. That's probably just because this was a sample paper, they didn't have that. So again, just write down whatever answer you get in your calculator if you don't see anything that it tells you to round it to. So continuing on with this question, it says work out the percentage of the volume of this box that is taken up by the 24 cans. Give your answer correct to 1 decimal place. So obviously the 24 cans don't take up all of the volume inside in the box. There's little small spaces of air in between that. So they wanted to find out what is the percentage of the boxes taken up by these cans. So from previous questions, we found out that 1 can had a volume of 407.15 centimeters cubed. In this box we have 24 cans. So we want to see, well, what's the volume 24 cans would take up? So to do this, I'm going to multiply 1 can by 24. That gives me an answer of 9,771.6 centimetres cubed. Now we know the volume of the 24 cans, and from the previous question we have the volume of the entire box, and that was 12,441.6 centimetres cubed. So the question wants us to write a percentage of the volume that the cans take up in terms of the box. So to do this, I need to write it as a fraction first. So the 24 cans has a volume of 9,771.6 over the volume of a box, which is 12,441.6. So to turn anything into a percentage, I first write it as a fraction, and then we're going to multiply that fraction by 100 over 1. And that gives me an answer of 78.5397%. So the question asked me to give my percentage to 1 decimal place. So I'm going to round it to 1 decimal place, which is the 5, ask the neighbour 3, and that will remain as 5. So it gives me 78.5% of the box is taken up by the 24 cans. So the last part of the question then is, there are a number of different ways of arranging the 24 cans so that they can be packed into a rectangular box. The dimensions of the box may be different for different arrangements. Find the dimensions of the rectangular box required for a different arrangement of the 24 cans and show your working out. So basically there's lots of different answers you could give for this. They're asking you to rearrange the 24 cans so that they're still in the shape of a rectangular box, but different in the diagram they gave you previously. So one way that you can do this is you could have 2 cylinders going back as your width, and you could also have 2 cylinders going up, and you could have 6 cylinders then going along your width. That would give me 24 cylinders because I'd have 2 along my width, 2 as my height, and then that would give me 4 in one row, which would, if I multiply by 6, gives me 24 different cylinders. So if I was to work out those dimensions, the length would be 6 cylinders diameter, so it would be 6 multiplied by 7.2, which would give me a length of 43.2 centimetres. My width would have 2 cylinder diameters going back, so it would be 2 multiplied by 7.2, which would give me 14.4 centimetres. And then my height was 10 for each cylinder, so I have 2 going up. That would be 2 multiplied by 10, which would be 20 centimetres. So that would give me the dimensions of a different box or a different formation that I could keep the 24 cylinders in. So say my height is 20, my length is 43.2, and my width is 14.4. As I said, there's multiple different ways that you could do this question. There's no right or wrong way, okay, as long as you have the 24 cans catered for and that they're fitting into the rectangular shape box. Okay, so that concludes today's lesson. So we covered a lot of questions there on length, area and volume. As you can see, formulas playing a big part in this section as well. Really important to highlight in your question, what are they asking you to find? Is it area? Is it volume? Is it the length, the radius, stuff like that? And then what shape they're asking you to find. Is it a 2D shape or 3D shape? And once you kind of can pick those out of the questions, you should be able to generate some formula either from memory or from your formula booklet. And that's a really good way to start the question. Once you get your formulas down, the question will kind of fill out for yourself. So I hope you enjoyed today's lesson and that you got good value out of it, and we'll see you again soon.